Good morning. My name is Emily Shaw. I have an opportunity to talk to you all a bit about the work that I and my colleagues have been doing at the University of Iowa, and to provide some context for the very interesting content that we've been working with. I've affectionately nicknamed this project the Shot in the Dark Project, because this turn of phrase conveys some of the hopeful uncertainty of both our recent efforts at the University of Iowa Libraries and those of the late 1950s Iowa-based research team whose scientific legacy we are working to steward. So, Iowa. The first thing most people think of is probably corn, maybe caucuses, and perhaps the future birthplace of James Tiberius Kirk. You might not immediately think of landlocked Iowa as a seat of the U.S. space program, though last year's announcement by University of Iowa professor and plasma physicist Don Gurnett that Voyager 1 had reached interstellar space has helped to correct that perception somewhat. Iowans have a pioneering spirit and a history of exploration, and not just of the land west of the Mississippi River. In 1958, a few years before NASA came into existence, a team of researchers from the University of Iowa helped to make one of the first major scientific discoveries of the space age. Launched on the last day of 1958, Explorer 1 was an aptly named rocket. Developed in collaboration with the Jet Propulsion Laboratory, the Army Ballistic Missiles Agency, and the Naval Research Laboratory, Explorer 1 was the first U.S. satellite to be put into orbit around the Earth as part of the International Geophysical Year. Explorer's research team was based in Iowa City at the State University of Iowa, now called simply the University of Iowa. The team was led by Professor of Physics and Astronomy, Dr. James Van Allen, and comprised of an impressive group of research graduate assistants, including Drs. George Ludwig and Carl McElwain, and others. Personal journals and correspondence of George Ludwig, pictured here second from the right, revealed that the launch of Explorer 1 was a bit rushed. As we all know, the Soviets had beaten the U.S. into space, having launched Sputnik in October of the previous year, 1957. Explorer was designed to measure cosmic radiation as a function of altitude, latitude, longitude, and time. It had a number of different instruments on board. However, it had no onboard data logger. This tape recorder, developed specifically for the Explorer rockets, was not ready in time for Explorer 1's launch. It was finished soon thereafter and sent into orbit aboard the Explorer 3, which was launched in July of that year, so not too far after. The data from Explorer 1 was captured at receiving stations around the Earth, noted by name on this map of Explorer's orbital path. Each station operator was told when Explorer was scheduled to pass overhead so that they could turn on their reel-to-reel tape recorders and record the data transmitted telemetrically by the satellite as it passed by. Each tape recorded up to 15 minutes of audio data and recorded data from up to 7 channels on 7 tracks. After each recording window closed, and when Explorer had moved out of range, the station operator packed up the tape and sent it to Iowa for analysis. These are the actual tapes, this one from Quito. Back in Iowa City, each Explorer tape was played back and the data was printed out into graphs that looked like this. Each second of data was represented by 1 centimeter. So a 15-minute recording could produce a paper graph 9 meters long, about 30 feet. Many of these graphs persist in the university archives. Figuring out if and how to digitize them and present them for screen delivery has been a bit perplexing. A small army of Iowa students helped to convert these graphs into numerical data that could then be computed. And while analyzing the data from Explorer 1, a curious anomaly emerged. At certain altitudes, the radiation data fell to 0. In the absence of data, in that noise, lay the big discovery. By the time the Explorer 1 data was fully analyzed, Explorer 3 was already in orbit and with more sensitive instrumentation. Explorer 3 confirmed what the data gaps in Explorer 1 suggested: the existence of large belts of charged particles surrounding the Earth, soon thereafter dubbed the Van Allen radiation belts. Dr. Van Allen and his research team captured the imagination of the American public. Dr. Van Allen is pictured here in his research lab, explaining his discovery to Walter Cronkite. This discovery had a significant impact on the development of telecommunication and for manned and unmanned space exploration. So what happened to all of the tapes? As the all too familiar story goes, the tapes went into a basement where they sat for decades, no longer useful for active research, but too important to throw away, and with no permanent archival home. So fast forward to 2009. Special Collections at the University of Iowa got a phone call from the facilities manager of a building on campus that used to house Dr. Van Allen's research labs. He wanted to let the libraries know about several thousand musty-smelling tapes in the basement, some with the words Explorer and Vanguard written on their boxes and cans. Unfortunately, the basement storage area had minimal environmental controls. There was significant mold growth, including the cardboard, Ampex, and Scotch tape boxes, and many of the tapes themselves. On a campus still reeling from massive flooding the previous year, an emergency grant from the state of Iowa was secured to clean, rehouse, and move the tapes into the main library. 2 years later, when I was hired as the library's first digital preservation librarian, one of the first projects assigned to me was to secure funding and get the Explorer 1 data tapes digitized. A generous grant from the Iowa-based Carver Foundation was given to the libraries to do this work, to digitize the tapes, and to share the data and associated archival materials with the public. The libraries would make the full data set available to scientists to analyze contemporary tools and methods and weave an engaging narrative of early space exploration at Iowa for members of the general public. Our friends at the Media Preserve managed to track down a machine very similar to the original, the one that was originally used to read the data. The head of audio engineering here, Kanya, converted the audio signals into WAV files, producing about 1.5 terabytes, including all the metadata and derivatives, for about 700 tapes. And that's as many as there were as far as we can tell. As our project team assembled at the University of Iowa Libraries, one thing became immediately clear. None of the librarians and staff who normally work on digital projects like this, myself absolutely included, so please keep this in mind during the Q&A, none of us had any expertise in near-Earth research, near-Earth physics, rather. So we reached out to our colleagues in the physics department, who now work and conduct the research out of Van Allen Hall. The partnership has been invaluable. Our colleagues in physics have been tremendously enthusiastic about our efforts to preserve the legacy of their field and of their department. They've helped us track down Explorer 1's orbital ephemeris data set, which was digitized by Google from the collections of the University of Illinois at Urbana-Champaign and is now preserved in HandiTrust, which we learned is critical to interpreting the audio data recorded on the tapes. So the data is digital. Now what? So the machine that was used and the original machine. Our work with this data is very much in progress. With guidance from our colleagues in the physics department, we plan to prepare the audio data and ephemeris data set to be archived with the National Space Science Data Center by packaging it in the common data format. We're also working with a professor of journalism and Van Allen biographer to weave an engaging narrative. Lab notebooks and personal journals will be made available for crowdsourced transcription through the library's DIY history platform. And our work with this data raises many interesting questions without easy answers. Archiving and sharing research data is a really hot topic in research libraries and research spheres, and libraries are struggling to figure out what our role is and how to make a meaningful impact without necessarily having the expertise, the scientific cred, or the infrastructure to do so. By claiming the digitized research data as part of our archival collections, we've committed to preserving this product of faculty research in perpetuity. So what do we do? What do we do now if these tapes if we had not digitized these tapes? What would happen to them? We learned recently that there was a warehouse full of tapes that had been destroyed about 3 years ago on our campus. What would we have done if we had found those? We don't know what they contain. We know that Explorer 1 hinted at a very important scientific discovery, but we're not certain about the scientific usefulness of that particular data set. It has a lot of historical value. So I'm going to just leave you with those questions that we can hopefully explore a little bit more in the Q&A, and play you a little clip from one of them.
This is Blossom Point, Maryland, recording the run of the 1958 Epsilon. Predicted our station at 0538 Zulu time.
It's not easy listening.